Solving quadratic equations by the quadratic formula. Now, it's quite possible that we will ask you to solve by completing the square, in which case we would head that algebraically determine and ask specifically for completing the square. But there is the quadratic formula that can be used in solving, and we may allow you to use that as well. So where does it come from? Well, let's start with a general quadratic equation. Ax squared plus bx plus c equals 0. And I'm going to actually solve this by completing the square, but this time we don't have numbers, we have this general equation. So my first step is get rid of the a, divide everything by a. I can do that because this side is 0. So I have x squared plus b over a x plus c over a equals 0. Okay, remember what to do. We need these two terms, the x squared plus b over a x, leave some space, equals, we move the constant term, right? C and a are just constants. Over to this side, become negative c over a, leave some space. I want to make a trinomial square. To do that, I have to square a binomial. It's an x with a plus sign. Half of b over a is b over 2a squared. Take the b over 2a, square that in order to complete the square, and this will be plus b squared over 4a squared. And let's add that here as well, plus b squared over 4a squared. Well, we come down here, equals. We need to add these two. In order to do that, I need like terms. So negative c over a, I'm going to have to multiply by 4a over 4a because I want a denominator of 4a squared. So a times 4a is 4a squared, and negative c times 4a is minus 4ac. Just to make life a little bit easier and neater, since that's a negative, we'll go b squared minus 4ac over 4a squared. Okay, so we've got the b squared over 4a squared. That's here. The negative c over a, remember, is the same as negative 4ac over 4a squared. And this is basically equivalent. If we simplified this part down, we would end up with negative c over a. The 4's would cancel. We have a negative. The a would go into the a squared, leaving you an a in the bottom. We'd have the c and the a. Okay, what do we do now? Well, we take the square root of both sides. The square root of this side is just the expression, so x plus b over 2a. The square root of this side will be plus or minus. This doesn't have a square root, so we're going to write it as the square root of b squared minus 4ac. And this does have a square root. The square root of 4a squared, the square root of 4 is 2. The square root of a squared is a. So we have a 2a. And you'll notice, hey, we've got 2a in both denominators. So I'm going to move this up a little bit, and we'll write our final answer. So I'm going to move this over. X equals negative b plus or minus the square root of b squared minus 4ac all over, right, all over 2a. Since we had a 2a here and a 2a here, we have that common denominator of 2a. Here's the negative b over 2a, this part here. And here's the plus or minus b squared minus 4ac all over 2a here. And you can memorize this. You can use the tune of Pop Goes the Weasel. I hesitate to do this as it will be saved for immortality, but here it goes. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. You can find much better renditions of that on YouTube if you look. So that's the quadratic formula. That's the derivation. This is the formula that we will be using. You will get this formula on a formula sheet, so you won't have to memorize it. You won't have to know how to do this derivation, but I don't think it's going to hurt you to have seen that it comes from just completing the square on a general quadratic equation. So for the remainder of this video, I'm just going to go back and we're going to solve the 3 quadratics that we did by completing the square using the quadratic formula. Back in a sec. Okay, here was the first one we did. X squared plus 10x plus 11 equals 0. Now we have to realize this is in the form ax squared. In order to use the formula, you have to identify a is 1, b is positive 10. We don't need to write the positive, we just write 10, and c is equal to 11. So in order to use the quadratic formula, you must identify a, b, and c. Start off, always write out the formula. Negative b plus or minus the square root b squared minus 4ac all over 2a. So we have our values of a, b, c. Write down the formula. Always, always, always. Math is formula substitution. So substitute in negative 10. Had b been negative, I would just make this term positive, right? But it's negative 10 plus or minus the square root of 10 squared minus 4 times a, which is 1, times c, which is 11. Extend that radical sign out. It's got to cover the whole thing. All over 2 times 1, 2a. And now we just basically go through and we simplify this. So negative 10 plus or minus the square root. This will be 100. Now here's a key. This term, the b squared term, will always, always, always be positive. So even if b is negative up here, which would mean that in this particular case it would turn to a positive, b squared, whether it's positive or negative, will always give you a positive value. Okay, so don't even put negative 10 squared into your calculator if that was the case. Just go 10 squared. Minus 44 over 2. Okay, we need to simplify. Negative 10 plus or minus the root of 100 minus 44 is 56 over 2. Now, since 56 is at the least 4 times, so let's just move over here. Root 56 is the root of 4 times 14, which is root 4. What I'm looking for is a perfect square that goes into 56, right? 2 squared, 4. Does 4 go into it? Does 9 go into it? Well, 4 does. So we write it as the root of 4 times 14, which is root 4 root 14, which is 2 root 14. So coming back here, negative 10 plus or minus 2 root 14 over 2. Now the 2 will go into the negative 10, will go into the 2, will not go into the 14, it goes into this. The 2 is a factor of that. So I'm going to divide everything by 2. Negative 5 plus or minus root 14. Okay, and if we compare that with our answer from before, we'll see that they should be the same. Negative 5 plus or minus root 14. So very important that you are able to turn an entire radical, that's all that's going to come out of this, is an entire radical, into a mixed radical. And then if you can, you make sure that you cancel, factor and cancel. In essence, really, this becomes 2 times negative 5 plus or minus root 14, and then the 2 here will cancel with the 2 down here. Okay, but whoops, didn't want to cross that off. I'm all over the tablet here. This is our answer, and this is our answer cleaned up. Well, making it worse than before. Negative 5 plus or minus. Always remember the plus or minus. Right? That's how we get the 2 roots. Root 14. Okay, 2 more to go. Okay, here's the next one. A, in this case, is negative 1/3. B is negative 7. And C is negative 17. Formula: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's go. We're going to fill this in. We're going to work it out. There will be fractions. There'll be fun with fractions. Negative b. So we've got negative negative 7. I'm just going to write that as a 7. Plus or minus the square root. Negative 7. I'm going to put this in brackets so that when I square it, I'll recognize that it's negative 7 times negative 7 to give me positive 49. Minus 4. Negative 1/3 and negative 17, so 4ac. Extend that. This is all underneath, right? And it's all over 2a, 2 times negative 1/3. Okay, let's go simplify. 7 plus or minus the square root. Well, negative 7 quantity squared. Remember, this is always, always, always positive. So positive 49 minus, okay, these two together are going to make a positive, right? A negative times a negative, and then we'll be subtracting. So we have, there's no common factor. The 3 doesn't go into anything. So we have 4 times 17, which is 68, divided by 3. Okay, so it's minus a positive, so it's minus 68 thirds all over negative 2 thirds. At which point you'd say, well, this really wasn't, it's not nice. I'm not happy. I got fractions all over the place. Is there a better way? Well, since that's equal to 0, remember, we can multiply by negative 3. Giving me x squared plus 21x plus 51 equals 0, right? So instead of going through the pain of the fractions here, because this will eventually simplify down, but multiplying by negative 3, we have this, and now we have a simple a is 1, b is 21, c is 51. I've already written the formula. Let's go substitute in x equals. So negative b now becomes negative 21 plus or minus the square root of 21 squared. That's a positive. I'm not going to put it in brackets. Minus 4 times 1 times 51 all over 2 times 1. So negative 21 plus or minus the square root. So this is 441 minus 204. We've seen this number before, right? Because we did this example. So that's 237 all over 2. And that's basically where we're going to leave this, right? Because there is no further simplification. I can't make the 237 simpler. I can't make the 21. Here, we can make things simpler, right? I would need to take the 49, multiply it by 3 to get a common denominator here, and then try and work the 3's out of there and all of that. And if we were going to a decimal equivalent, if we wanted numbers, x equals, and I want to get a number out of this, say negative 21 plus root 237 divided by 2, then I can just work that out on my calculator, as I could with this. Also, I could just work this out on my calculator. I would probably simplify these two first, right? 49 would be 147 over 3, which would give me some expression here. But I think you'll agree this is a simpler form of the expression. So, if we have fractions, let's get rid of them. Let's simplify this. They will have the same x-intercepts, okay? They are different graphs. This graph obviously opens down. This graph opens up. if we did go to decimals and graph both of these, we would see that they had the same x-intercepts, and that's really all we're after here, is getting the same x-intercepts. Okay, and sometimes we just want a decimal equivalent, then you just plug in to your calculator -21 plus root 237, hit enter, then divide that by 2, or you need brackets, bracket -21 plus root 237, close the bracket, so it'll do that first, and then divide by 2. And here, same deal, you could go 49 minus 68 thirds if all you were looking for was a decimal equivalent. Okay, let's do one more. Okay, this is the format we started in. In order to use the quadratic formula, we need it in the form ax squared plus bx plus c equals 0. I'm not going to bother dividing by 3. I don't want to introduce a fraction into this one. In the last one I did want to get rid of the fraction, but here we have none. So a is 3, b is -12, c is -19. Formula goes x equals x is equal to -b plus or minus the square root b squared minus 4ac, not that I write all that well, all over 2a. Okay, substitute in math formula, substitution. So -12, you could write it as -12, I'm just going to write it as 12, plus or minus the square root -12, I'm keeping this in brackets. I really want to remind myself that I'm squaring the quantity -12, minus 4, a is 3, and c is -19. Extend the radical out, it needs to cover the whole thing, over 2 times 3, 2 times 3. Okay, let's work this. So 12 plus or minus the square root, this will be positive 144. Now you notice it's minus, and this will all be a negative, so that's going to be plus, and we need 4 times 3 times 19, which is 228 all over 6. Let's just go up here and we'll continue over here. So x is equal to 12 plus or minus the root of 372 all over 6. Now, I think this will simplify it, and how can I do that? How can I figure it out? Well, let's pop back to grade 10 for a moment. You maybe learned how to use a factor tree. There's a nice song with that too, but I'll leave you to look it up on YouTube. It's factored down a tree. So 372 is 2 times, 372 divided by 2 is 186. 186 will be 2 times, 186 divided by 2 will be 93. 93 will be 3 times 31. And here's the thing, 31 is prime, 3 is prime, but you notice we have the 2 2's, which means 4 goes into that, so let's just work that here. So root 372 is the square root of 4 times, oh, hang on. Okay, where were we? This is 4 times 93, all under the root sign, which is root 4 root 93, which is 2 root 93. Okay, and again, there is no simplification beyond that. Okay, so x equals 12 plus or minus 2 root 93 over 6. Now, common factor between 12 and 2 and 6 is 2, so I can divide, as long as everything divides. So the 12, the 2, and the 6 all divide by 2, giving me 6 plus or minus root 93 all over 3. And that is our final answer. And at this point I'm thinking, well, that's a little different than the answer I gave in the last one, which was x equals 2 plus or minus the root of 31 thirds. And the question is, so are these the same, and what should I have done to fix this? So I'm going to go fix this. I'm going to move down here. So when I had in the previous video x is 2 plus or minus root 31, let's write it as root 31 over root 3. Now if you remember, we don't like radicals in denominators, so I'm going to multiply by root 3 over root 3. Okay, now all I've done is just strip this out, okay, and we're going to fix this. So this will be root 93, and this will be 3. So back to here, this will be x is equal to 2 plus or minus root 93 over 3. Oh, hang on. To put this over 3, I'm going to have to make that a 6. Right? So the root 93 is over 3. I need to write 2 as 6 over 3, which will give us 6 plus or minus root 93 over 3, which is the same as this. So I think I need to go back and do a little bit of editing to that one video to fix up this. So you may not see it as a mistake in the other video because it's got to be fixed.